Hello everyone. Today we are going to learn about shared exclusive locking under DBMS. It is one of the concurrency control techniques used in DBMS, which is called as shared exclusive locking. So what we will learn today, what is shared exclusive locking? Then we'll see example of shared exclusive locking, and lastly we'll see drawback of using shared exclusive locking protocol. So first we will learn about what is shared exclusive locking. Now there are two things in this shared exclusive locking protocol. One is a shared keyword you can see, and other one is an exclusive keyword. Now what is shared lock? Shared lock is denoted by letter S, which you can apply on any data item. Now data item is suppose A. Okay, data item, or you can say data variable. Now A is a data variable. You can apply the shared lock on this data variable A using symbol or letter S. Right, like this you have to write. So this is a shared lock on data item A. Okay, in which the data is stored. I can store the data like this to 20. So shared lock is used only to read the data item. Whatever value is there no inside A, that is read using shared lock. You cannot write any data inside the data variable A. You can only read the data from this data variable A using shared lock. So now shared lock is applied on A. So I can only read the data which is present inside A, that is 20. So many transactions may hold lock on same data item in shared locking mode. For example, there are two transactions which are happening simultaneously on my system. Suppose transaction 1 and this is the transaction 2. So in the transaction 1, I want to read the data item A. So when you read any data item, you can apply the shared locking. Transaction 2 also wants to read the data item A. So you can apply again shared lock on this data item A in transaction 2 also. So many transactions, now in my case I have a two transactions, transaction 1 and transaction 2, may hold the lock on same data item. They are holding the shared lock on the same data item, that is data item A. You can see transaction 1 also is holding data item A, shared lock on data item A, and transaction 2 is also holding the shared lock on data item A. So many transactions may hold a lock on same data item in shared locking mode. Next is exclusive lock. Now exclusive lock is denoted with the letter X. Now when you use exclusive lock on any data item, you can read or write that data item. For example, I have a data item A or data variable A. Now inside this data variable, I can read also data from this variable, and I can write also data from this variable. Like I can write the data 10 inside this variable using exclusive lock, and I can read also from this using exclusive lock. Okay, so suppose this is a transaction 1. You can apply the shared exclusive lock on this data item. You have to specify in the bracket which data item you are applying this lock on. I am applying the lock on data item A. So when you apply the shared exclusive lock, you can read the data item and you can even write the data item. Okay, you can read the data from the data item and you can even write the data from into the data item. Both you can do when you use the exclusive lock, unlike shared lock. In shared lock only you can read the data item. Okay, like this. When you apply the shared lock, you can only read the data item. You cannot write anything inside the data item. You can only read this value which is present in the data variable A, that is 10. You cannot write. As in exclusive lock, you can write the value inside the data. You can change and make it 20. So when one transaction holds the lock on data item, no other transaction can access the lock in exclusive mode. Now you can see transaction 1 is having the exclusive lock on A. Now no other transaction can have exclusive lock on A because it is already held by transaction 1. If I say over here exclusive lock on A, this will be wrong. Why? Because exclusive lock is already given to transaction 1, and when one transaction is having the exclusive lock on same data item, other transaction cannot have it. Okay, request won't be granted. When one transaction holds lock on data item, no other transaction can access lock in exclusive locking mode. So now we'll see one example on shared exclusive locking protocol. Suppose I have a two transaction. I'm giving the transaction 1 name as T1 and transaction 2 name as T2. Now, in transaction 1, I just want to read the data item A. Now, suppose I have a data item or data variable A, and in this 20 is stored. Now, I just want to read this 20 value. So, I can just apply read of A. Transaction 1 only wants to read. So, read of A, and for this I can apply what? Shared lock. In shared lock, you only read. Okay, now in transaction 2, you wants to apply the exclusive lock simultaneously. So exclusive lock means what? You can read also and you can write also. Okay, so you can read the data from A and you can write the data from B. So transaction T1 will use the shared lock to read the data item A and it will unlock after reading the data. U is used for unlocking. Okay, S is used for showing it is a shared lock and X is used for showing it is a exclusive lock. Okay, now exclusive lock, you can read the data item A, write the data item A, and you can unlock the data item A. So shared lock and exclusive lock both can be locked and unlocked after usage. So this way you can put shared exclusive locks for your transactions which are running concurrently, means simultaneously, and you can achieve the concurrency control. Now we will see what are the drawbacks of using this shared exclusive locking protocol. When the concurrency control concept came, different types of locking protocols were introduced. First locking protocol that was introduced was shared exclusive locking protocol. So this protocol was having some disadvantages or drawbacks. So because of this, other locking protocols came into existence. Okay, like two-phase locking protocol, rigorous locking protocol, timestamp based locking protocol. So all those locking protocols came later on after shared exclusive lock. Okay, so what was the drawback or disadvantage of this that we'll see now? So first drawback is it do not guarantee serializable schedule. Now what is serializable schedule? The meaning of serializable schedule is I have a transaction T1 and T2, both are running or executing simultaneously. Now, T1 wants to read the data item A and also wants to write into the data item A. Now this is the data item A. So T1 wants to read the value first, whatever is present, and then he wants to write also, change the value, what is present inside A. Okay, and T2 wants to what? Only read the value inside the data item A. Now again T1 wants to read and write the data item B. Whatever the value is present inside data item B, he wants to read and write. Now what is happening over here? First T1 will execute, that is T1 will read and write the value inside data item A. Then again T2 will read the value from the data item A. Then again the T1 will read the data item B and write into data item B. So first T1 is happening, then T2 is happening, then again T1 is happening. So it is looping one after another, it is happening. Serializable means what? First T1 should get complete properly, it should finish its task completely, then only T2 should happen, or T2 should complete first and then T1 should happen. But here it is not happening like that. First T1 is coming, then in between only T2 is coming, then again T1 is coming. Okay, so in this case we say it is a non-serializable schedule. Serializable actually means what? T1 should finish its task completely before T2 can start, or T2 should complete its task first and then only T1 can start. Either of these should happen. Then only we can call it as a serializable schedule. Okay, one should complete its task completely before the next transaction can start. But here it is not happening like that. First T1 is doing its task, then again it is going to T2, then after T2 again it is coming back to T1. Okay, so it is looping. One is coming, then second is coming, then again first is coming. So this type of schedules are called as non-serializable schedule. Okay. For this non-serializable schedule, we can apply shared exclusive lock. For example, T1 is doing both read and write operation on A. So we can apply the exclusive lock and we can unlock. So once it unlocks, we can give the shared lock to T2 on the same data item A and we can unlock it. After unlocking, we can again give the shared exclusive lock on data item B to T1. Why shared exclusive lock on B? Because it is doing both read and write operation and we can unlock the B. So here we can easily apply shared exclusive locking on this non-serializable schedule. So shared exclusive locking protocol do not guarantee serializable schedule. From this example we can come to know. Next is it do not guarantee irrecoverable schedule. Now what is the meaning of this irrecoverable schedule? Now again, concurrency means more than one transaction will execute simultaneously. So T1 and T2 are executing simultaneously. So T1 want to read the data item A and wants to write into data item A. A contains suppose the value 10, and since it is reading and writing the value on data item A, we can apply the shared exclusive lock. After usage, it can unlock the data item A. Once it unlocks, T2 can use the shared lock on A for reading the data item A. It can also apply the exclusive lock on data item A for reading and writing again because T1 has unlocked it. And after applying shared and exclusive lock, it will commit. Okay, now value of A was 10 in transaction T1. It has read 10. Then it has written suppose 20. So this 10 got changed to 20 because write operation has been performed by T1. And after that it is suppose unlocked. Then T2 will read what? What is the value of A? It will read in shared mode 20 it will read because 20 is written inside A. So T2 will read 20. Then exclusive lock is applied. So again T2 will read 20 and write suppose 30. He wants to write suppose 30. He will write the 30 and he will commit. Now suppose in between what happens till the time it is getting T2 is getting committed, in between suppose something happens to this transaction T1, it gets crashed. So it has to do the rollback. Go back to the starting position. Okay, where it was there previously. And this transaction T2 is already committed. So you cannot change it because it is already committed and it is having value 30, which is not correct. Okay. So consistency is not achieved in this because you cannot roll back T2 because it is committed transaction. T1 was not committed. So we rolled back and went to the starting position. But T2 we cannot change it. It will remain 30 only, which is not correct. When you apply the shared exclusive lock, your schedule can be irrecoverable. Now in this case, it is irrecoverable schedule. We have applied the shared exclusive lock over here, but the schedule is irrecoverable. Next is it may not be free from deadlock. Now deadlock means what? Any process waits infinitely for the resource, then we call it as what? That process is in a deadlock state. So shared exclusive lock may not be free from deadlock. It may have a deadlock. That is a disadvantage of using shared exclusive lock. So how we can prove that it is not free from deadlock? We'll see. We have a two transaction T1 and T2. Both are executing simultaneously. T1 is having shared exclusive lock on A, meaning it wants to read the data item A and write also into the data item A or data variable A. Okay. T2 is applying exclusive lock on data item B. So T2 wants to read and write into data item B. And they have not unlocked their locks. T1 is still using it, T2 is also still using B. They have not unlocked their locks. Okay, they have an exclusive lock on data item A and B respectively. Now again, T1 wants the exclusive lock on data item B. Here, exclusive lock will be granted to T1 because no other transaction was having exclusive lock on A. So it will be granted to T1. Here also exclusive lock will be granted to T2 because no other lock was having exclusive lock on B. So it is granted. But here it won't be granted because exclusive lock B is already given to T2. T2 is already having exclusive lock on data item B. So T1 has to wait. Wait till what? Till T2 unlocks this exclusive lock on B. Till T2 unlocks, T1 has to wait for the data item B to apply exclusive lock. So this one has to unlock it first, T2, then only T1 can have it. So it will wait. Similarly, T2 wants to apply exclusive lock on A. Again, it won't be granted because exclusive lock on data item A is already taken by transaction T1 and they have not released it. T1 has not released the exclusive lock on data item A. So it won't be granted to T2. So T2 has to what? Wait. So both are waiting for each other to unlock their locks. T1 is waiting for T2 to release B and T2 is waiting for T1 to release A. So both are waiting for each other. T1 wants the resource B and T2 wants the resource A, which are occupied by each other. So they won't be free and they won't be given to them. So in this situation we call it as what? Both the processes or both the transactions are in deadlock. T1 is also in a deadlock, T2 is also in the deadlock, because they won't be able to complete their task because they are infinitely waiting for each other to release their own resources. Now last drawback of shared exclusive locking is it may not be free from starvation. Now what is the meaning of this? Deadlock and starvation, only one difference is there. Deadlock is, in deadlock, process waits infinitely for resource. In starvation, process waits finitely for resource. So this is the difference. In starvation, process will be able to complete its task, but it has to wait for a long time. So that is called as starvation. When we apply shared exclusive lock to the transaction, it may not be free from starvation. This lock won't help transaction to be starvation free. Transaction may have to go through starvation. For example, we have a transaction T1 and T2 executing simultaneously, and we have also transaction T3 and T4, okay, where we can request and grant the permission for locks. Okay, so we have shared lock and exclusive lock, shared lock and exclusive lock. So whenever the request for shared lock is given, if shared lock is granted on transaction 1, then request for transaction 2 for shared lock A can also be given. So this is possible. So yes, both transactions can have a shared lock on the same data item at the same time. Both can have a shared lock on the same data item, that is A, at the same time. Okay, so shared possible. One transaction is having shared lock on A, other transaction wants the exclusive lock on data item A at the same time. It is not possible. Because shared means you are only reading, but exclusive means what? You are reading and writing also. So here read write conflict will happen. So no, not possible. Similarly, suppose T1 is having exclusive lock on A, then it will read also and write also because it is having the exclusive lock on A. Then T2 cannot have a shared lock on A, because if it has a shared lock on A, again write read conflict will happen. So this is also cannot be granted. So no. Shared exclusive lock cannot be used at the same time by both the transaction. Only shared lock can be used by both the transaction at the same time. And if you have the exclusive lock at the same time on the same data item, it is not possible, because here also write conflict, read write conflict also will happen, and write read conflict also will happen. So no, not possible. So only shared lock can be given to both the transactions simultaneously. Both the transaction can have a shared lock at the same time. They cannot have exclusive lock at the same time, or shared exclusive or exclusive shared lock at the same time. So now we'll see the starvation problem. Shared exclusive lock may not be free from starvation problem, that we'll see now. Now T2 has having the shared lock on A and T1 wants the exclusive lock on A. So it has to wait, because shared and exclusive cannot be given together unless T2 unlocks A. Shared we can give, but shared exclusive we cannot give together. So shared lock is already taken by T2 on A. So it is suppose unlocking over here down. Okay, before that only T3 wants to have a shared lock on it. So you can give shared lock on it, because shared can be given simultaneously to multiple transactions, because they are just reading. Shared means they are just reading, so you can give simultaneously. But exclusive lock you cannot give, because you are writing also in exclusive lock. Okay, so T3 will get the lock from T2. Again T1 has to wait. He won't get the lock or shared exclusive lock on it, because T3 took it. Before T2 can unlock, T3 took it. Now T3 will unlock the lock over here. After unlocking, only T1 can have the exclusive lock on A. But before T3 unlocks, T4 is asking for the shared lock on A. So request is granted. T4 will be given shared lock on A. Okay, so again T1 has to wait. So T1 is waiting for a long time. So T1 has gone into starvation. This particular We have applied the shared exclusive lock, but it is not free from, your transactions are not free from starvation problem. They can starve. So this is the problem of shared exclusive locking. So now T4 will unlock it over here somewhere, and after that only now T1 can apply exclusive lock on data item E. So here T1 is starving for a long time. So this is the drawback of using shared exclusive lock. Since it is not guaranteeing irrecoverable schedule, it may not be free from deadlock, and it may not be free from starvation. So these four are the main drawbacks of shared exclusive locking protocol, and because of these drawbacks, new locking protocols came into existence. We'll see those protocols one by one in the upcoming videos. So this was all about the shared exclusive locking protocol under concurrency control techniques in DBMS. Thank you.